Hi, I'm Katie Early. Welcome to Part 3 of the Number Sense module, grades 6 through 8. You will be hearing my voice and that of my three colleagues, Danielle Reynolds, Brian Lindeman, and Michelle Sanchez. We are excited to share this part of the module with you and hope you find it beneficial to the students you serve. Here are the topics we will be discussing in Part 3 of the module. As you read these, please be aware that we are emphasizing two big points in this module: make sense of and visuals. Just because we are exiting grades TK through 5 doesn't mean that visuals are less important. Visuals are highly effective in how our brains make sense of mathematics. For example, a student might be able to follow an algorithm that divides 1/3 into 5, but if they can draw a picture, then they are showing they can make sense of 1/3 and how many times it goes into 5. What visuals help us make sense of mathematics? Please take 1 minute to jot down your thoughts. Now we will watch a video regarding the importance of visualization in mathematics, linked in the description below.
We are needed for math learning? We're not babyish?
Yeah, we are really important for brain growth and math performance.
The fingers are right. Brain studies show us that there's an area of our brain that lights up when we calculate that's actually seeing fingers, even when we're not using fingers. And it's really important to develop that area of the brain. Brain studies also show us that whenever we work on maths, there are actually 5 brain areas that are needed, and 2 of them are visual pathways. Our brains want to be thinking visually when we work on maths, and it's really important to see maths visually. Improving maths performance actually means improving communication between different brain areas, including those 2 visual pathways. So when you're working on a maths problem, it's really good to represent it in different ways. For example, draw a picture of the idea, maybe write a story about it, make a graph or a doodle or a sketch. It's easy to get the idea in school that maths is a narrow subject, that it's all about calculating, but that's actually not the case, and maths is really a broad, open, visual subject that's about making connections and exploring patterns.
A few points you may wish to consider include: fingers are a way to think visually in mathematics and can be used at any age. Visualizing is essential to learning mathematics. 5 areas of the brain light up when we do mathematics, and 2 of them are visual. Mathematics is a broad, open, and visual subject. Supporting students in the classroom to explore, find, and develop visual ways to understand mathematics is helpful in sense-making. In grades TK through 5, manipulatives are commonplace in classrooms to help visualize mathematics for younger students. In the middle grades and beyond, this should be a continued practice because our brains at every stage want to think visually about mathematics. You will see several examples in this module of how visuals can continue to help make sense of the mathematics in the middle grades.
Let's now look at the major focus areas for number sense in grades 6 through 8. Students still interact with number lines to help make sense of and reason about numbers. They study proportions, ratios, percents, and relationships, among these. They also begin to see numbers in more general ways and how letters can stand in for numbers and expressions, which sets the stage for algebra. Many examples and short snapshots of how these are developed in classrooms are provided throughout Chapter 3 of the framework. See the whole chapter at this link. This part of the module will explore these 3 focus areas in more detail by looking at ways to bring in examples of visual tools in the classroom. We will start with number lines and how they help students make sense of and reason about numbers. In grades 6 through 8, the number line model continues in importance as students begin to experience numbers in more abstract ways. Previously, a student might count 5 M&Ms and find the number 5 as a quantity on the number line. However, 5 is not only a quantity and a position on the number line, it is also a distance between 2 quantities on a number line, like between 0 and 5, or between -1 and 4. In 6th grade, we can't exactly count -5 M&Ms, at least not in the same way we've done in prior grades. But we can still use a number line to help children conceive of -5 as a number that exists on the line, just as we did about +5. For example, -5 is a position on the number line that is 5 units to the left of 0. In addition to this, one way for students to think about the difficult concept of the negative of a negative being positive is to think of opposite as on the other side of 0, to visualize the negative of -5. Open number lines are still important visuals in 6 through 8 as well. Proportions, ratios, percents, and relationships are among these.
Let's now look at a scenario. Hiking at a constant speed, Dominica hikes 4/5 of a mile every 2/3 of an hour. Thinking about this idea of hiking at a constant speed over time, what do you notice? What do you wonder? Pause here and jot down a couple of noticings and wonderings. Maybe you notice that the units are miles and hours. Or could we use minutes instead? And a constant speed seemed important here. Or you notice that she has walked almost a mile. So it's reasonable to wonder how long would it take for her to walk 1 full mile? Or you wondered how far would she hike in 1 hour? This last question is the one we want to answer. How far would she hike in 1 hour? Pause for a moment and consider some ways to answer this question. Depending on their funds of knowledge, students could use ratio tables, strip diagrams, and even graphing the miles and hours on a set of coordinate axes. While these approaches are productive, we will emphasize a double number line approach, since number lines form a crucial through line in the learning progression of number sense. Before we get back to the hiking problem with fractions, let's revisit prior knowledge of how double number lines work using a whole number example from previous grades. Kiko is baking cookies for her class, using a recipe that calls for 4 cups of flour and 3 cups of sugar. To make enough for everyone, she pours 8 cups of flour into a mixing bowl. How much sugar should she use? We set up a double number line with 2 number lines, stacked and labeled with each quantity. Using a single tick mark through both lines, the location of 0 is marked, indicating the proportional relationship between the 2 quantities. Note that double number lines should only be used in proportional situations. Using another single tick mark to indicate the initial ratio of flour to sugar, students are ready to reason within the model. Since the next tick mark is at 8 cups of flour, we recognize that we need to multiply the quantity of flour by 2 to get 8, so we do the same below, resulting in the 6 cups of sugar needed. A double number line approach encourages students to recognize the principle that multiplying one quantity by a factor, in this case 2, necessitates multiplying the other quantity by the same factor in order to preserve the ratio. Thus, students have visual evidence to match with their intuitive understanding that if Kiko doubles the amount of flour, she must double the amount of sugar. Similarly, if Kiko wants to bake a half batch of cookies, she would halve the amount of flour and thus halve the amount of sugar. We can think of halving as dividing by 2 or as multiplying by 1/2. As students become accustomed to using multiplication and division to move around a double number line, this reinforces their ability to think multiplicatively in reasoning about proportional situations. Using the same double number line approach, let's now revisit the hiking problem with Dominica, where the goal is to find how far she hikes in 1 hour. As before, we set up 2 lines with the given quantities and the goal labeled as single tick marks passing through both lines. One approach is to go small to then go big. If we cut 2/3 in half to find how far Dominica hikes in 1/3 of an hour, we do the same above to determine that she hikes 2/5 miles in 1/3 of an hour. So she hikes 2/5 miles in 1/3 of an hour. To find how far she hikes in 1 hour, we jump from 1/3 to 1 hour by multiplying by 3 and do the same above. Thus, Dominica hikes 6/5 miles in 1 hour. This utilizes the fundamental Common Core understanding from grades 3 to 5 that fractions are built from unit fractions. 2/3 is 2/3, or 2/1/3. A second approach could be to move past 1 hour and come back to it. By recognizing that tripling 2/3 hours gives us how far Dominica hikes in 2 hours, we can then find how far she hikes in 1 hour by dividing by 2. Note that we are still dividing by 2 and multiplying by 3 as we did before. In this approach, we use the flexibility of open number lines, in which we still place priority on ordering tick marks increasing from left to right, but are more flexible about the distance between them to focus on the jumps or calculations. A third approach is to combine both jumps seen previously into one. In our first 2 approaches, we multiplied by 3 and divided by 2. If we recognize that dividing by 2 is the same as multiplying by 1/2, we can now see that it really is 2 multiplications at work here, by 1/2 and by 3. That gets us to the same location as the previous approaches using a single jump of 3/2. Another more computational way to see this is to recognize that determining how far she hikes in 1 hour is actually determining her rate or speed in miles per hour. We can find this rate by setting it up as a quotient. 4/5 miles per 2/3 hours is 4/5 divided by 2/3, which is computed by standard algorithm as 4/5 times 3/2, which we can simplify to our final answer. Notice that this approach connects nicely to our double number line approaches, particularly the last approach of scaling by 3/2.
Here is an example of a visual tool that can help build conceptual understanding when finding percentages of numbers. When given a problem like 40% of 820, we can draw 2 bars, both split into 10 equal pieces. One bar represents 100% of 820. The other bar will be our 820. On the percent bar, we break up the sections into 10% increments. Students then notice or calculate that 820 divided into 10 increments would be 82. Now on our 820 bar, we can label these increments going up by 82 each time. We then visually see that 40% of 820 is the same as the value of 328. We have covered a handful of ways to visualize some mathematics in grades 6 through 8. Here are some additional resources and visual tools that can help in the area of proportions, ratios, and percents. While these are more formalized ways to help students think visually that can be introduced in a classroom setting, we want to emphasize the point, like Joe Bowler does, that any drawing or doodle created by students can have value, be explored, and further developed to help make sense of a problem and give it meaning.
In the middle grades, students are now entering a new and exciting world where they generalize their understanding of numbers as known values to now seeing quantities that can vary and finding relationships between such quantities. However, we don't need to rush to variables as the primary means for representation. Expressions and equations should flow from a visual understanding of unknown quantities first. Let's look next at how we can encourage students' sense-making by introducing them to a variety of ways to represent quantities, both visually and symbolically, and help them form meaningful connections between the two.
An example of a tool that can be used to explore unknown quantities evolves from the idea of a hanging mobile. Some people think of mobiles as the kind of thing you might hang over a baby's crib. There are also artists all over the world who use the concept of balance to create pieces of art. After this concept is presented to students, we can then begin to present them with puzzles that are created with this idea of balance in mind. These mobile puzzles are available in many curriculums and for free on several websites. Several of these can be found at solveme.org. These are helpful to a student in the beginning of their sense-making of unknown quantities because they are visual, allow for multiple ways to approach the problem and discover the weights of the unknown shapes. These mobiles preview the concept of balance in equality, and they preview some of the moves we make that we later call inverse operations or legal moves in some books, when algebraically manipulating equations. After several of these, a teacher may start to ask the question about how we could express this written out and less visual. She may begin to encourage students to write down their ideas about how to represent the weight of a red circle with a let statement, or what we call an assignment statement. For example, let R represent the weight of the red circle. Once this happens, students can begin to write number sentences or expressions. We can now begin to ask questions like, what number sentence or expression could you write for this mobile? Pause to notice some possible student responses that may come up when a teacher asks this question and documents it for a class discussion, not unlike a number talk. You may have noticed that this shows a window into how students are starting to explore the representations of what is unknown and what is known, what is equal, and what can be combined into a short and more simplified form. For example, one student may write out 2 hexagons, while another says 2H. Any answer can allow for students to be sense makers and share their thinking.
Number mobiles can be a tool an educator uses to help visualize and make sense of unknown quantities. It can also be a tool that slowly and purposefully moves a student's thinking towards symbolic representation with variables. Other tools that can have similar effects or even go beyond and into later high school algebra include pan balances and algebra tiles. Algebra tiles are a completely different tool that serve as another example of a strong visual tool for students while they struggle to make sense of unknown quantities and relationships. Algebra tiles have some benefits later on for students, like visualizing the idea of combining like terms and zero pairing. They can also be helpful in later high school mathematics with quadratics and area models. Pan balances are similar to number mobiles, allowing students to explore the idea of balance with unknown quantities as they puzzle things out. They also can connect to equations and how both sides are equal or balanced. Pan balances also have other tools and connections that can be found on websites like NCTM, where they are used to help students visualize the answer to a system of equations.
Tape diagrams are yet another visual tool that enables students to build expressions and equations that model unknown quantities and relationships. With tape diagrams, a student is able to connect an abstract expression like 4x to the more concrete visual representation of lining up rectangles. This more concrete approach allows students to visualize the abstract work of solving equations. Our goal for this part of the module was to show you that the use of visual models, just as they do for elementary grades, can enrich middle grades students' development of number sense. Moreover, visual models will also benefit their learning of more advanced mathematics in high school and beyond.
So we've just spent some time thinking about the mathematics in the framework, particularly the number sense chapter. In addition to mathematics, we also want to consider how we are integrating social emotional learning principles into our mathematics instruction. Consider the question above and jot down a few of your thoughts. Self-awareness, social awareness, and relationship skills are some of the areas that can be developed in students as they engage in mathematics. Some students may need more support, encouragement, and opportunity to discuss their thinking publicly. However, with continued intentional experiences integrated into our learning environments, students will continue to increase their social emotional competencies and therefore increase their sense of agency. For example, if we provide some opportunities to discuss and share things like which one doesn't belong, it supports them. Let's dig a little deeper into the big ideas of social emotional learning and some specific connections to visual math and models. The Collaborative for Academic and Social Emotional Learning, or CASEL, has identified 5 core competencies of social emotional learning. Those competencies include self-awareness, self-management, social awareness, relationship skills, and responsible decision-making. Supporting students' social and emotional development does not need to happen in isolation or as a separate set of lessons. It is possible to integrate skill instruction and practices that supports SEL development within the context of your academic curriculum. Let's dig a little deeper into what that might look like for each of the 5 SEL core competencies. Self-awareness is the ability to understand one's own emotions, thoughts, and values, and how those impact how you behave. When participating in activities that focus on the use of models and visual approaches, we are supporting the development of self-awareness by helping students learn to consider available resources and approaches and how they might use those resources to deepen their own understanding, identify their feelings about the mathematics task and solving problems using multiple approaches and strategies, identify their individual strengths and challenges, and have a growth mindset. Self-management is the ability to manage one's emotions, thoughts, and behaviors effectively in different situations and to achieve goals and aspirations. When participating in activities that focus on the use of models and visual approaches, we are supporting the development of self-management by providing opportunities for students to learn how to think metacognitively about the connections and relationships they are making in their thinking, make sense of problems and available tools and approaches before jumping into a solution, set personal goals, and monitor and evaluate their progress during and after a problem-solving experience, utilize strategies to persevere when solving challenging problems and identifying relationships and connections between ideas, and communicate and justify thinking to the group while honoring the thoughts and ideas of others. Social awareness is the ability to understand the perspectives of and empathize with others, including those from diverse backgrounds, cultures, and contexts. When participating in activities that focus on the use of models and visual approaches, we are providing opportunities for students to develop their social awareness by understanding the approaches and mathematical arguments of their peers, recognizing strengths in others' problem-solving approaches, demonstrating perspective-taking, empathy, and compassion when working with others, and showing care for how others are feeling as they tackle mathematical tasks. Relationship skills are the abilities to establish and maintain healthy and supportive relationships, and to effectively navigate settings with diverse individuals and groups. When participating in activities that focus on the use of models and visual approaches, we are providing opportunities for students to develop relationship skills by working cooperatively with others by sharing ideas and listening to others' perspectives, actively listening to the thinking of others, deciding whether they make sense, and asking useful questions to clarify thinking and strengthen connections between ideas, communicating effectively and attending to precision in sharing thinking and reasoning, seeking to understand the perspective of others and resolve conflicts constructively, and offering support to their peers when needed. Responsible decision-making is the ability to make caring and constructive choices about personal behavior and social interactions across a variety of situations. When participating in activities that focus on the use of models and visual approaches, we support the development of responsible decision-making by allowing students the opportunity to identify multiple approaches to problems and the connections and relationships between those approaches, learn how to use information to make decisions or choose appropriate strategies, anticipate the consequences of one's actions and choose appropriate actions, and reflect upon and choose appropriate ways to contribute to the learning community. These are just some of the ways the SEL competencies can be developed while we are supporting our students' mathematical agency. We know you will have other ideas to extend those lists as you integrate SEL into your math instruction.